That is the sound of about 7% of the entire world's greenhouse gas emissions. We've talked about it on the show before, but it bears repeating. Concrete is everywhere. It's one of the most used materials on Earth, second only to water. Every new road, bridge, apartment building, and hospital probably starts with a line item for a lot of concrete. And that isn't changing anytime soon. But what does need to change is the cost we're paying in terms of greenhouse gas emissions. Roughly 7% of global emissions come from the production of cement, one of the core ingredients in concrete, the glue that holds concrete together. But that also represents an opportunity, a big, hairy, audacious goal to pursue as we reduce emissions around the world. And a great place to start on that journey, tucked away in the breathtaking Rocky Mountains of Alberta, is the Lafarge cement plant. Home to 160 employees, originally built in 1906, it's the largest plant of its kind in Canada. So we sat down with Stephanie Voysey, Head of Sustainability and Environment for Western Canada with Lafarge Canada, to discuss carbon capture, turning limestone into skyscrapers, and decarbonizing cement production. Here on Carbon Copy.
My name is Stephanie Voysey. I work for Lafarge Canada, and I'm the interim head of sustainability and environment for our Western Canada team.
I'm really excited to have you on the show, Stephanie. Thank you for joining us.
Thank you. Very excited to talk to you today.
So let me start with a question that I think everyone wants to know. What the heck is the difference between cement and concrete?
Yeah, a lot of people do get this confused. There is a difference. I like to think of cement as the ingredient that's used to make concrete. So think of it as cement is the flour, whereas your concrete is your cake, your final product. Concrete is what we use to make our sidewalks, our building foundations, infrastructure, the bridges that we're driving our cars over. And so cement is the heavy intensive building material that's produced at our cement plants. It's the powder. When you mix it with water, aggregates, and sand, you get concrete, and as concrete hardens, you get the strength that's required in order to have your buildings and your bridges that last for many, many years to come.
Well, that's a perfect analogy, if for no other reason than because I'm a really big fan of cake.
Yeah.
So the Lafarge cement plant is just off the Trans-Canada Highway between Calgary and Banff, and is a familiar sight to travelers entering the Canadian Rockies or leaving the Canadian Rockies. Would you say it's the most photographed cement plant in the world?
I think so. It's very likely it is. At least in Canada, I can say that. We had a lot of people stopping on the side of the Trans-Canada Highway to take photos of it. It is a sight to see. So yeah, no, I can probably think it's one of the most photographed.
Aside from being situated in one of the most scenic areas of the world, when you travel past the plant, there are a couple features that stand out, a big dome and a very tall tower. What are those?
Yeah, so the tower is a preheater tower. There are two kilns at our Exshaw facility, Kiln 5 and Kiln 6. That means that there was a Kiln 1 to 4 before that. The plant's been there since 1906. And we've had significant upgrades to the site. Historically, the use of the production, of cement was done through wet kilns, which is very energy intensive because they actually made a slurry out of the raw materials, and then they would heat that up in the kiln. So as we progress in technology, we now have a preheater tower and a shorter kiln. And so the preheater tower allows for air to material heat exchange in a cyclone to allow for that more efficient heat transfer so that we can have higher production and lower energy use per ton of clinker. And clinker is the ingredient that's produced in our kiln, and it's what's used to make cement. And so what you're seeing there is the two towers, so two kiln lines that are making clinker, and it's heating up the raw materials to the temperature that's required to make clinker, which is 1,450 degrees. And so we also have a dome there to ensure that we are protecting the clinker that we make. It's a very highly valuable product to make sure that we're protecting it from the environment. Moisture is pretty bad for it. And also to ensure that we're keeping our fugitive dust emissions to a minimum, because we are operating within the town of Exshaw, to ensure that we're thinking about our neighbors and our stakeholders that we're working with in the community.
So speaking of neighbors and stakeholders and community, I understand that you share a fence line with a community. Is that correct?
Yes, we do. Yeah, we are right beside residents of the Exshaw community, and also right beside the school there in the Exshaw, in Exshaw.
So how does that affect the way you operate the facility and interact with the community?
Yeah. So we do have regular community meetings with the people of Exshaw. Whether or not we're right beside a community, or in this case, like literally our property abuts against the Exshaw school. We just want to make sure that we're any of our environmental emissions are kept within the required, within our permitted limits, and that includes dust. Dust is typically the biggest issue that we face at a cement plant. Making sure that we have those mitigations measures in place, water sprays, keeping our speed limits to a minimum to ensure that we're not migrating dust from our property, making sure that all of the maintenance is completed on our equipment, so that they're in good working order.
So you told us a little bit when you talked about the visual elements of the plant, about how the process works. But if I can dive a little bit deeper, can you tell us at a fairly high level the process of how cement is made? What ultimately goes on at the plant?
Yeah. So we have a limestone quarry at the Exshaw plant. Most cement plants around the world are located right at a limestone deposit because that is the major raw material that's used in the production of cement. So we have a calcium source, which is the limestone. We have a silica source, an alumina source, and an iron source. And typically you have between four to six raw materials that make up these four ingredients that you need. We grind all those raw materials to a fine powder using either a ball mill or a vertical roller mill, and then that powder is stored in a silo. And then you take that powder now, we call it kiln feed, and it goes into the preheater tower at the very top of the preheater. At the same time, in the kiln and also in the preheater tower, we have vessels, cyclones, where that heat exchange happens that I spoke about before. Because we have the preheater tower, there are cyclones in the tower that allow for additional heat input. So there's burners in the tower as well, so that we can heat up the process even more. And then you can have the ability to add fuel there. So in that fuel addition, we're heating up the air to about 2,000 degrees to allow us to heat up the raw materials to 1,450 degrees. By the time the material gets to the top of the tower, the air there is about 300 degrees. By the time it gets to the bottom of the tower, it's about 1,000 degrees. So that's the material is still a fine powder, but now it's 1,000 degrees. When it goes in the kiln, it goes through the process of becoming clinker, in which it becomes almost like a molten lava. And then it clinkerizes to these little nodes when it drops into our cooler, where we quickly quench the material, and then we have a solidified matter called clinker. Now, Portland cement is a combination of clinker, gypsum, and limestone. And historically, the clinker volume has been about 90%, 5% gypsum and 5% limestone. Over the last, I'd say 12 to 13 years, we've had a lot of advancements in making Portland cement into Portland limestone cement, so that we can reduce the amount of clinker that we put into cement and have the same strength profile. So we then increase the amount of limestone instead, which is why it's called Portland limestone cement, up to 10 to 15%, keeping the same amount of gypsum. So reducing the amount of clinker within the cement allows us to decrease the greenhouse gas footprint per ton of cement. Um, so about a minimum 10% reduction in greenhouse gases as part of our production of PLC, or Portland limestone cement.
Speaking then of greenhouse gas emissions, what are the primary sources of emissions in making cement?
So greenhouse gas emissions in the making of clinker, which is the main ingredient in cement, about 35 to 40% of it comes from the combustion of fuels to heat or kiln. So then right now at Exshaw, we've got 100% natural gas that's being used in both kiln 5 and kiln 6. And then the remaining amount, the 65 to 70%, comes from calcining, which is the liberation of CO2 from the limestone as we heat it up. So as the material is coming down our preheater tower, we're probably getting to about 90 to 95% calcine. Most of the CO2 has been liberated at that pace. So we can reduce our greenhouse gas emissions from the combustion of fossil fuels through co-processing. So that's the use of waste-based fuels, alternate fuels instead of fossil fuels. However, the emissions from calcining are currently unavoidable unless we replace our main ingredient, which is limestone. So one way to look at it is to look at installation of carbon capture on site.
So, if I understand correctly, in essence, there are two major sources of emissions. One from burning fuels to generate heat, because you have to heat the limestone ultimately to about 1,450 degrees Celsius, if I heard you correctly. And two, carbon dioxide that gets released from a chemical reaction. Did I get that right? And then the second one is a larger source of emissions. Would you say that's a tougher problem to solve?
Yes, yeah, it certainly is. I mean, Lafarge is a member of Wholesome, and Wholesome is a global group. And Wholesome's done a lot of research and analysis, and they have had some more advances in looking at alternate raw materials to replace limestone, but we're not yet there at capacity to look at what can we do at Exshaw, what can we do at our Richmond facility and our other facilities in Canada. And so at this point, carbon capture is our only solution to decrease the emissions from calcining.
So let's say then you could get your heat without using fuels, or even using fuels that don't cause greenhouse gas emissions. You would still have all the emissions from the process itself, or roughly 2/3 of the emissions from the plant.
Exactly. Yeah, we'd be left with 2/3 of the emissions. So for the plants that have been able to reduce their greenhouse gases through co-processing or replacement of the fossil fuels, they've been able to decrease their emissions profile that way, but there's still that leftover 2/3 of the GHGs that are unavoidable.
Well, that's a perfect lead into what I want to ask you about. Your organization, Lafarge, is working on some really cool projects with support from the government of Alberta's TIER fund through our organization, Emissions Reduction Alberta, or ERA, to address multiple emission sources. So let's start with the fuels that heat the kiln. Can you tell me about that project and what you're hoping to accomplish?
Yeah. So Exshaw currently uses natural gas to heat up both Kiln 5 and Kiln 6. Through our new low carbon fuel project, that's hopefully going to be in line come early summer in 2023. We're looking at putting in a system to accept, a system to hold the fuels that we would be processing and to inject it into our Kiln 6. So the LCF project is for Kiln 6 alone because the system is able to use alternate fuels. The new LCF system will provide alternate fuels for our Kiln 6 line. So it is mostly construction demolition waste, non-recyclable plastic, and shingles that will be used as the alternate fuels to replace natural gas used on site. We're looking at a minimum 50% replacement of fossil fuels. And obviously, as the plant, this will be the first time for them to co-process alternate fuel. We'll see kind of a slow start in the beginning as our operations begin to get used to the fact that they're now using waste-based fuels. Unlike natural gas, which has a constant heat, you have variations in moisture, in heat value, in material size that can affect the energy output that the material can provide to our system. And so our operators will need to kind of relearn how they operate our kiln.
So can you tell me where things are at today with the project and what's left to be done?
They broke ground about a month and a half ago. And so they are in the midst of construction right now through the winter, which is probably not ideal. But we're optimistic that they should be ready to go come May or June of next year. So they're good. They're actually building like a storage facility for alternate fuels that will come in. They'll already be processed, and so the alternate fuels that come in will be stored within a building, and then they'll have conveyance that will take it into Kiln 5 preheater tower, where it will be injected into our calciners.
So I can imagine that burning things like construction and demolition waste and plastics and shingles might have raised a few eyebrows in the community. How informed are the residents on these initiatives? And are there any health impacts in terms of air quality that people need to be worried about?
Yeah, we've been quite open with the community throughout this entire process. We've had open houses. I think the most recent one being the open house that we had about a month ago. And so they've had other ones prior to that, just talking about, you know, what is the process of co-processing? How do we ensure that it's safe? So just to clarify, Exshaw is not the first facility to do this. There are many cement plants around the world who have been co-processing for years. When people think about burning waste-based fuels, I always get a description of people about like the open barrel of, somebody's burning a tire or something. You get this huge plumes of black smoke. So it's a controlled process, right? The use of energy within cement manufacturing is the most expensive part of our process. It's in our best interest to ensure that we're taking advantage of the heat value of the material we're using, and using it to the extent to make clinker. And so within our kiln system, we have a controlled atmosphere. We control oxygen, airflow, temperature. That's all controlled and monitored to ensure that we have complete combustion, right? The black plumes of smoke that you see when people are burning things openly is, incomplete combustion, the production of carbon monoxide in the air, and that's kind of a hint that you're not burning it properly. So, as part of our system to ensure that we know that we're not increasing contaminant pollutants into the atmosphere as we use these new waste-based fuels, we worked with Pembina Institute, University of Calgary, and Queen's University to look at dispersion modeling. What are the potential contaminants that could come off of the system as we migrate from natural gas to waste-based fuels, and then looking at Queen's University actually did a lot of testing in their labs on combustion of these fuels to see what are the potential contaminants that could come away from it. So yeah, there was also a life cycle analysis that was done by those three parties, looking at what are the reductions in greenhouse gases through the use of waste-based fuels. So there was a lot of work in the background to ensure that, one, we provide the comfort to the people in the community, that the change in the process will not result in a change in our air emissions. And what the data showed was there was a negligible change in pollutant emissions from our facility. And we see that also in our sister facility at the Richmond Cement Plant, who currently co-processes 40% alternate fuels in place of natural gas.
You talked about a storage facility that's being built for the low carbon fuels, alternative fuels. Will there be any other new buildings or structures on site? And when this project is complete, will it look any different to the Albertans and the tourists traveling through on the highway?
I think if you look at it from the scale of the facility, they probably wouldn't notice very much of a difference. While the building is not going to be small in size, from the highway, they'll probably only see a small portion of it versus, the large tower or the clinker dome that they see in the background.
We talked about greenhouse gas emissions. We talked a little bit about air quality or emissions that could potentially impact air quality. Are there any other environmental benefits associated with this project? For example, are we diverting waste that would otherwise go into a landfill?
Yeah, pretty much. Majority of all the alternate fuels that will be used um, have no other use and are going to a landfill. When we talk about construction demolition waste, a lot of it is stockpiled now and going to landfill. Non-recyclable plastics. We all love to recycle and wanna and hope that a lot of the materials that we're putting into the recycling bins that get picked up weekly are recycled. Majority of it is not, unfortunately, because the market isn't there to recycle it, and so we see that there's a better use for these materials than going into landfill, and it's also a reduction of methane emissions in the landfill if you look at it on a life cycle assessment.
Emissions Reduction Alberta takes action on climate change and supports economic growth. Our funding helps new and existing industries in Alberta reduce emissions while lowering costs, attracting investments, and creating jobs. That's why, since 2009, we've committed $884 million into 246 projects valued at $7.1 billion in public and private investments. To learn more, visit eralberta.ca.
What about cost? We often hear that addressing climate change is a costly proposition. We also hear that on a global scale, it's likely more costly to not address climate change. But from the plant's perspective, how does this impact the cost of running the facility?
Well, managing energy is very important in our industry. Fuel is very expensive, and we use a significant amount of it to heat up our kiln to make clinker in order to make cement. There are definitely savings that are gained by co-processing alternate fuels, but that is balanced by the additional effort that must be taken in order to use these fuels in our kiln. So there's additional testing that must be completed, and there's obviously inconsistent quality in regards to fuel and heat value of waste-based fuels. But we feel this is a necessary effort that we must take in order to reduce our greenhouse gas emissions from the combustion of fuels in our process, and it is a big part of our sustainability ambitions.
Okay, so that's the fuels portion of the emissions that we talked about. Let's talk about the other source of emissions, the larger source, the more difficult source to deal with, the carbon dioxide that gets released as limestone from the mountainside gets converted into clinker, or the primary ingredient in cement. Tell me about the project your team is working on with support from the Tier Fund through ERA. What's that one about?
Yeah, so we're very excited to embark upon the carbon capture journey. And so, as part of our Kickstart grant that we received from the ERA, we've started a scoping study to determine what could be the best available carbon capture technology that we would implement on site. So there's amine-based technologies, solid sorbent, and membrane. So we have 5 different carbon capture technologies that we're working with right now. They've received a basis of design, so that talks about emissions on site, what does the profile look like, and we're expecting reports from them by the end of the month or early December to look at what their proposal is for carbon capture on site. Now, we'll take those reports now, and we're going to proceed to a pre-feed study, so that's front-end engineering design. And we'll look at that study for pretty much all of 2023. And so we'll work with an engineering company to review what does carbon capture look like on site, right? So what people see from the highway is this very, very large facility, but when you look at the footprint, it's a very tight space, right? We have an old kiln on site, Kiln 4, which shut down in about 2017 when we upgraded Kiln 6. So there's a very small footprint that's available for that, and so we'll be looking at what is possible for installation of carbon capture on site. And then as well, what do you do with the CO2 after you capture it, right? You need to transport it and sequester it. And we're lucky enough in Alberta that is available for us. So we'll be working with a partner on transportation and sequestration as well.
Okay, there's a few things I want to touch on there. Thank you very much. Maybe first of all, you mentioned 5 technologies that you're looking at, and these, some of them are perhaps amine based, maybe solid sorbent based, maybe membrane based. Do you have any early indication of which of those might be the most suitable for your particular operations at Exshaw?
Yeah. I mean, yes and no. Um, because it's full scale carbon capture and we're looking at, flue gas that's not typical of other industries. A lot of people call cement flue gas quite dirty. We have NOx, SOx, heavy metals, dioxin and furans, and these things can be quite detrimental to a carbon capture process. So for amine, it could degrade the amine quite a bit due to those contaminants as well as the particulates. Even if after we polish particulates out from our baghouse, there's still minute particles in there that can affect the amine. Same with solid sorbent and membrane. I think amine technologies are more proven. There's been a lot of historical use of amine-based carbon capture technologies in other industries, so that potentially could give them a one step ahead than others. But we have other cement plants within the Wholesome portfolio, like in the United States, that's looking at cryogenic capture, and that's quite new. So I'm not saying that we have to go with a historical known technology. We're definitely open to considering new technology.
Well, I, for one, am excited to see where you land on that analysis and conversation. So you touched on this other piece that I wanted to ask about, but if you don't mind, I'm going to maybe dig a little bit deeper. Capturing emissions on site at the Exshaw facility is a part of the puzzle, a very large part, I might add. But once you capture those emissions, they need to go somewhere for permanent storage. Where will that CO2 go, and how do you plan to get it from Exshaw to wherever it needs to go?
Our partner will look at sequestration options within the Bow Valley to Calgary. And so right now there was Alberta Environment had one of the sequestration hubs that was granted was I think it was the Bow Valley hub. And so that's one we're looking at. But we have also been in discussions with other parties who have proposed other sites as well. And so that will be part of the review that's going to look at, because we also want to consider that, there's Lafarge in Exshaw, but there's also other industries like Greymont and Baymag in that area that are also looking to decarbonize. And so we've been talking to them about partnering together in order to ensure that, the pipeline that gets us to a sequestration hub will be available to them as well. So not just looking at Lafarge's emissions, but looking at decarbonization of other industries in that area. And it will be a pipeline. I was talking to somebody about this. They were like, are there going to be, hundreds of trucks every day moving from the sequestration hub to our plant site? And that's just not really efficient. It's got to be a pipeline.
So where will the pipeline be built?
It's likely, when we look at a map, if we're heading from Exshaw towards Calgary, if that's where eventually the sequestration hub's going to be, it'll likely follow the highway all the way there. But that will be part of the pre-FEED assessment that our partner will be completing.
What do you personally see as the biggest challenges of this project?
One big challenge that is difficult for other people to understand is, there's more than one kiln at our Exshaw facility. There's two kilns. They operate independent of each other. So, and they're not close to each other. They're about 500 meters apart. And so as part of the project, we need to determine, do we put a carbon capture facility at each kiln and design for the maximum capacity for each line? Or do we have one facility where we pipe the flue gas from both kilns to one, right? And when I say they operate independently to each other, they have different maintenance schedules. They have different outages. So if I'm designing one system to support two lines, and we have ups and downs in our processes, we have shutdowns, sometimes planned, sometimes unplanned, it's difficult to determine how exactly we design a system to accommodate all of those factors. So that to me is the most difficult part of this process.
And now, going back to the other project for a second, does burning alternative fuels affect or impact your ability to capture carbon?
No. I don't believe it will. Right. There is a potential increase in the moisture in our stack gases and a little bit potentially in NOx, depending on difficulties that the operators might have in learning to use the fuels. But no, we see the emissions profile at our Richmond plant that's using 40% alternate fuels and their CO2 content versus Exshaw's, who's now still using 100% natural gas. And there isn't that much of a difference in it. So we don't see an issue in regards to co-processing alternate fuels with carbon capture in the future.
If this project is successful here, what does that mean for other Lafarge plants around the world? Can this approach be used elsewhere, or is it unique to the Exshaw facility?
No, I think it certainly can be carbon copied, and that's one of the benefits we see with doing this at Exshaw. Right, in Alberta, we have the ability to sequester CO2, which makes it, it makes the unknown portion of carbon capture a little bit easier to handle. If we talk about our Richmond cement plant in BC, those sequestration options are not yet available right now. So then we have to look at, if we have full-scale carbon capture, what do we do with that CO2? Do we have to look at utilization technologies? Whereas in Exshaw, that portion is kind of, it will be addressed, but there is a way out there. So if we're able to implement carbon capture at Exshaw, we can share those learnings within our Canadian cement plants, not just Lafarge, but also cement plants from our competitors as well. We see this kind of as a learning process where everybody really needs to share this information in order to make sure that we move the needle forward in regards to our sustainability ambitions and going to net zero to help with climate change.
This has been merely a glimpse into the fascinating world of cement manufacturing, clinker manufacturing, and addressing climate change. If people want to learn more and follow your team's progress, where can they go?
Yeah, so the Lafarge Canada website has a lot of this information on there. There's also lafargeexshaw.ca. That website's been developed to help our neighbors, stakeholders who are interested in the LCF project. We're eventually going to put carbon capture information on there as well, so they can certainly go there. And like I mentioned before, we're part of the Wholesome group. So Wholesome also has a lot of this information on our sustainability ambitions on their website.
Is there anything we didn't talk about that you'd like our listeners to know? Anything I didn't ask you about, or any closing thoughts you'd like to leave with us?
Yeah, so one thing that I always want to tell people is, cement and concrete. I believe the stat is that concrete is the second most used material in the world, right? And we understand that we have a very big impact on emissions. I think of last glance, it was 6% of all greenhouse gas emissions in the world come from cement manufacturing. And so in the process of co-processing, decreasing the amount of clinker in cement, looking at more efficient plants like K6 at Exshaw, carbon capture, we're moving in the direction we need to and looking at decarbonizing the building materials that we all need, right? We're constantly building better cities, building better communities, and it's just a part of the innovation that Lafarge and Wholesome are going through as part of a building materials company. This is quite important to us, looking at our 2030 ambition and eventually looking at net zero as part of our business.
Thank you very much for your time today, Stephanie. It was an absolute pleasure talking with you.
You're welcome. Thanks. It was very nice talking to you as well.